We want to finish this section with a small example. We look at the binary adder channel. In this channel, the encoder 1 and the encoder 2 send a message through a channel, and the decoder receives it, and he receives a 2 if both encoder encode the 1 into the channel. He receives the 1 if one encodes the 1 and the other 0, and the other way around, and he receives 0 if both encoder encodes a 0. So the binary adder channel, as you see, have here as input alphabets binary alphabet. So x1 and x2 is equal 0, 1, and the output alphabet have 3 symbols. It's 0, 1, and 2, and y is equal x1 plus x2. So the channel is deterministic. So the mutual expressions in the formula before became entropy, and we get this region here. Just to see this, I just open you the whiteboard and put it on the whiteboard. Just a moment, I open a whiteboard, and then we get the following bound. So our bound we have is that R1 is lesser equal than h of x1. That's obviously that it have to be uniform. So this is equal 1 then, if you take the maximum over all x1. So R2 is lesser equal than h of x2. That's the same, with the same argument, we get also 1. And the sum R1 plus R2 is bounded by h of x1 and x2. And this is equivalent for this channel as h of x1 plus x2. Now, if you look at this entropy here, then you see that x1 plus x2 is equal 0 if x1 and x2 are 0. So this happened with probability 1 over 4. x1 plus x2 is equal 1 if x1 is 1 and x2 is 0, or x1 is 0 and x2 is 1. So this happened with probability 1 over 2. And then we have x1 plus x2 is equal 2 only if x1 and x2 are both equal 1. And this happens with probability 1 over 4. So if we now calculate the entropy, we have here 1 over minus 1 over 2 times log 1 over 4 minus 1 over 2 times log 1 over 2. And this is equal, so if we estimate this, then we get here 3 over 2 log 2, which is equal 1.5.